All right, this video is going to go over pages 26 and 27 in your packet. It's just going over force graphs. So we're using velocity versus time graphs here. So remember, this is kind of a recap. So when you're looking at velocity versus time graphs, so velocity would be your y-axis, time would be your x-axis. Okay, if you're changing velocity over time, that means slope in this case is going to equal acceleration. So if you ever want to find acceleration on a velocity versus time graph, just kind of calculate the slope. So if you need a refresher, y2 minus y1 over x2 minus x1, or rise of a run, whatever you got to do. Now in this case, it says a box of mass 5 kilograms is lifted upwards, so do not forget this mass is here. Okay, a lot of times is students will get caught up in the graph, and then all of a sudden they forgot there was actually a value given up here, and then they get stuck. Okay, so we have a mass, just don't forget it's there. It says calculate the acceleration of the box. So we're just going to find the slope. So I'm just going to pick I'm going to pick the endpoints. Doesn't matter which points you pick. I'm going to start off with 0, 0, and then I'm going to end on 6, 24. Okay, so I'm going to do y2 minus y1, so 24 minus 0, over x2 minus x1, 6 minus 0, so 24 divided by 6, and you get an acceleration of 4 meters per second squared. That's all you got to do for acceleration. Now, calculate the net force. So remember, F net equals m times a. So this should be pretty easy. Our mass was 5 kilograms. We found that out in the beginning of the problem. Our acceleration is 4. So all I got to do is multiply those. So that means my net force is going to be 20 newtons. Now, how much force is being used to lift the box? So F lift is actually mass times gravity. Okay, it's like how much force is actually to take to get it up off the ground. Well, if you want to figure out kind of what weight is, okay, like if you were to lift you off the ground, I would have to overcome your weight and the force of gravity. Okay, so you're going to do mass times gravity. So mass would be 5. Gravity would be 9.8. Now, if you use negative 9.8, it's not that big of a deal. Okay, I know gravity is always pulling down. So technically, your weight would be a negative value. But if I'm talking about the force that's using to be lift the box, I'm the opposite of going down. I'm going up. So that's why we're going to use a positive 9.8 in this. But again, doesn't really matter. So 5 times 9.8 is going to give me 49 newtons. Okay. A hockey puck with a mass of 0.16 kilograms, so don't forget mass is there, slides across the ice rink and slows to a stop. Calculate the acceleration of the puck. So we're going to use our points. So we're going to say 0, 11, and then I'm going to use 6, 0. So acceleration y2 minus y1, so 0 minus 11, over 6 minus 0. So negative 11 divided by 6, and you get negative 1.83 meters per second squared. So there's your A. So there's your answer for that one. Calculate the net force. So mass times acceleration. So 0.16 times negative 1.83. And I get negative 0.29 newtons. So there's that one. Okay, so next one is a car of mass. I'm sorry, the typo is kind of this. A car of mass 400 kilograms. So there's your mass. Speeds up as shown below. So calculate the acceleration of the car. So I'm going to use points. So 0, 0, that's an easy one. And this one, what I got is I got 6.5, 30. So I'm going to do y2 minus y1. So acceleration is going to be 30 minus 0 over 6.5 minus 0. Now again, these graphs can be up to interpretation. We should be pretty close. So if you didn't get like exactly the same thing, like if you kind of used more decimal points and stuff like that, that's fine. As long as you're close and you can back it up with your math. So 30 divided by 6.5 gives me 4.62 meters per second squared. And there's my acceleration. So net force equals mass times acceleration. So mass would be 400 times my 4.62. And you're going to get 1848 newtons. A pickup truck of mass 600 kilograms. So again, apparently typos are just all up in this. Okay, mass is 600 kilograms. Calculate the acceleration of the truck from 0 to 4 seconds. So from 0 to 4 seconds, there's no slope. Okay, so acceleration will be 0. 4 to 6 seconds. So I'm going to use my points 4, 10. And then what I used was 6, 27.5. So I'm going to do my 27.5, y2 minus y1, so minus 10. Okay, over x2 minus x1, so 6 minus 4. And I get 8.75 meters per second squared. So again, as long as you're close, you're fine with whatever points you pick. Now I'm going to calculate the net force of 0 to 4 seconds. Well, if A is 0, if F equals M times A, that means net force has to be 0. So there's your answer for that one. Next one is I'm going to do my mass times acceleration. So my mass was 600 kilograms. My acceleration was 8.75. And you're going to get 5,250 newtons. So graphs are pretty easy. There's not much there, so that'll end that one.